Well, good morning. Another step in the saga. That's a Browne and Sharpe number 9 taper, which is what the spindle is. If I measure it here, we've got 170. Now what I'm going to do is mill me an arbor, or lathe me out an arbor. I've got one end turned already here, and I've got it about 185. And so 185 on this one, leave me about that much. In other words, the spindle will stick out that far, about 1/4 of an inch. Now, Browne and Sharpe taper. This is a 12-inch piece. There's so many thousandths per foot. I'm going to take this chalk off of here. I'm ready to start turning the taper for the milling machine, and I'll put it between 2 live centers and I'll get back to you. Alright, here's my arbor to be set up in 60-degree dead center here with a clamp on it that's going to driving dog. It'll enable this thing to turn. It's just a tad out of balance, but not enough to make any difference. This is not offset at all. If I was to run my bit in here until I touch off, I've got a 10,000ths I can play with, so I'm not worried about that. I'm just going real slow here. Okay, I just touched off. And if I engage it, it'll cut the... You can see it's cutting the same amount there. Because this was clamped before here in the 3-jaw chuck. Maybe a slight variance in it. But basically, this tailstock is dead center in the lathe. So I'm not worried about that too much. So the next thing I do is I'll figure out the length and how much it's offset. Then I'll take these screws right here and I'm going to move this tailstock this way, which will enable this whole piece to come that way, and I'll have it at an angle. And then when I start to cut here from right to left, this will give me the small end of the taper here, and I want to get this top in where my finger is to a point where it sticks out of the milling machine like 1/4 of an inch. And then this left piece here, I'll turn this down to whatever size cutting wheels I have. Well, some of you might find this interesting. This is the Machinery's Handbook. Basically, it gives you all of the sizes for various tapers. Here's a Morse taper. Tells you how big the plugs are, inside diameter, outside diameter, various sizes of taper, 0 through 7. Normally, this is one I made here. This is a Morse taper 2 that fits into the spindle of the lathe. Same as that dead center there. But the milling machine doesn't use a Morse taper. It uses a Browne and Sharpe taper. And this happens to be a number 9. So if we look down in here, we can see the taper per foot, small diameters, so forth, all the various dimensions and stuff here for tapers and sleeves. So, you know, basically this tells me that I've got 500 thousandths or half an inch taper per foot, and it just happens to be, by lucky accident, that is exactly 1 foot. No, actually I cut it exactly 1 foot. So anyway, we got some formulas here how to calculate how much offset we got. But basically, when we're dealing in inches and feet, it's taper per foot, and it says it's ½ inch. That means that I'm going to have to move this over half of that. So I'm going to move this over 1/4 of an inch. And what I'm going to do is set up a micrometers here, a dial indicator rather, so I can tell exactly how much it is, and then we'll start to cut this taper. Alright, I removed my tool post and everything, got this out of the way, and I've put my indicator here against the live center. This is all solid, so if I move any part of this over, the whole thing moves. It's not at an angle. Now I'm just going to use my little fine indicator here. I'm going to find a high spot. Alright, looks like the dial indicator is going down, going up, now it's starting to go down, so looks like the center is right there someplace. Now I'm just going to loosen up the adjustment screw here. There's one on each side. I'm going to loosen up the one on the other side, and I'm going to tighten this one, and I need to move this 250 thousandths. I'm just going to set this on 0 for now. And I'll do that off camera. It's all kind of bunched up tight there. But I'll set it for 0, then we'll move it over 1/4 of an inch. Alright, well, this is not meant to be a super how-to video on how to do this. You know, Tubal Cane, Mr. Pete 222, Ox Tools, one of the best is Keith from Turn Right Machine Works. There's a lot of good guys out there. It's how I learned how to do this. So anyway, I've got this here ready to start to turn it. Now I've got to move this tailstock towards me 250 thousandths. Alright, there's 100. That's all I've got on this side. I'll loosen this up a little more. I don't know if you can see. There we go. And 100. There's run out of movement again. Loosen up some more. Back to my adjustment screw. 200, 230, 250 thousandths. And then I'll go back to my first side. I should tighten that up. I'm still at 250 thousandths. This was loosened up just a little. I'll tighten it. And I'm still at 250 thousandths. Now, I don't know if you can see, but this is, at least I can see with my eye here, that's at a pretty good angle. It's moved over 1/4 of an inch. is exactly 12 inches long between centers. And the Brown and Sharpe taper number 9 is 900 thousandths or 500 thousandths, 500.50085. So I've moved it 250, which is pretty close for this, and that's what I've got here, 250 thousandths. So now we're going to put our cutter back on our tool post and start turning this taper. Alright, I've got my I'm using a little carbide insert here, which cuts pretty good. When I get down to the smooth finish, I'll switch to high-speed steel. This piece right in this area here, I need to make a flat on so I can tighten this up and loosen it with a wrench. So I'm going to wind up wanting this tapered end about right here. Now it's too big as it is, but I found that turning these things to the exact diameter, if I make a mistake, then it's too late. So I'm leaving it a little big, and basically what I'm going to do is I want this size to be like a quarter of an inch away from this collar here, or the face of this spindle. I don't want to stick away out here like this for a cutter. I want to try to keep it in close, because the whole bar is like a foot long. It comes way out here. So that's all I'm going to do. In fact, I should be set up. Let me just turn this on. Try to do this one-handed for you. I'm going to bring it here until I touch off. There's our touch off. Take it to the end. I'm going to dial in down here and put 5 thousandths in. And now it should cut a taper, and it should probably stop right along here someplace. And as you can tell there, it's getting thinner and thinner. Just quit cutting. Move it back to the start. I'm going to take off 10 thousandths this time, because I know that it will cut 10. That's 10 thousandths per side, 20 thousandths total. And let's just move it right along. Taper will get further up the shaft until it finally tapers out and quits cutting altogether. There we go, so it quit cutting. So I'm sure you've probably seen plenty of this. No need to watch this. I'll bring it back to you when I'm getting pretty close to having the taper finished. Alright, I made a few 20 thousandths passes here. I could have turned this small end down to a certain diameter and tried to match it, but I don't care about that. This is going to get cut off and drilled anyway for a bolt. One thing I'm concerned about is getting it close up here to the edge. This is probably 100 thousandths that I've taken off, 5 20 thousandths passes. And that's where the last one quit. 20 thousandths is extending it out another quarter of an inch. That's done. Run it back in. Take another 20 thousandths, gauge it. Simple matter of standing here, repetitive motion until it's done. I'll bring you back when we're pretty close to being finished. Alright, this is here someplace. I'm going to be within about ½ an inch of where I want to finish this taper up. I threw some oil on it there to try to give me a little smoother finish, but I don't know how well that worked. I'll finish this cut. I'm going to make one spring cut to try to get it to its final dimension, and then we're going to try to put it in the milling machine and see how well everything lines up. It's almost done right at the end here. Got a fan going. This smoke is really bad. It's killing my breathing. That and cigarettes. I quit smoking cigarettes. I need to quit doing this too. There it is, starting to finish, coming out. Alright, looks like I'm about a half. Alright, well, there's my finish. Good enough for a test. I don't know if you can see here, but this last final cut with a carbide tooth, you know, this is out of balance. I think this bolt is probably throwing it out, and it causes the whole lathe to vibrate in and out, and every once in a while it'll take a bite out of it there. But this will be good enough for a test frit. When I do the final cut, I'll be using a different bit anyway. So we'll pull it out of there and see how it fits into the spindle. Alright, here's the thing pulled out of the lathe and stuck into the spindle. I can feel it turn and grab right there. And as you see, I've got about an inch here. Like I said, I try to sneak up on these dimensions. I try to move it back and forth and up and down. I can't feel anything, so I'm pretty sure that the taper's good. What I don't know is how good the taper is in here. I tried to clean it up yesterday, but this is an old machine. It's probably got scores and marks. Next thing I'm going to do is die this one and then put it back in and give it a few turns, and this will show us where our high spots and low spots are. Alright, what I've done is take this and coat it with layout dye. Dykem spray dye. Now if you see there, I'm just turning this very slightly. Now I'll pull this out and we look for where it's hitting. See, I've got a gouge right there, one here. Ideally it would take all the red off, but it looks like I've got some just right here in the front. It's the only place that this is making contact. So that tells me that oh, there's a little bit right there. So it's got a little right in the front, about 3/4 of the way in, and I do looks like I got a couple little scratches in the back. So what this tells me is that I've either got right here in this area, I've got dirt right there, 1/2 an inch in. Let's try it here and see where it's at. Looks like it's on the bottom side here. Not that my taper's bad, but yeah, I can feel some scoring right here in in the spindle. Well, I'll work a little on that spindle and try to see what I can get this any better. Alright, what I've done, I've just taken some 220 sandpaper, which is pretty fine. I can feel the roughness inside this bore. Turned on the machine here. I'm just trying to clean this bore up. I know it's probably not the right way to do it, but I can still feel some scratches and scores right there in the very end of it. I could probably use something bigger, heavier grit, but this is not only taking out the spores, it's unfortunately making the whole thing bigger. But I'm trying to use my finger to put pressure on the places where it's been scored. Looks like it's sunk in the spun in the spindle and marked it. They do make a home for this, and that's probably what I'll have to do, is actually hone this thing. But for now, I'm just trying to clean it up. Yeah, I can still feel it just a little, but a lot better than it was. So I'll clean the grit out of there and we'll try a test fit again. Alright, I resprayed this. I'm going to put this in again. I know I got my screw up here. I'll just gently turn it in the bore here. See where it's marking it. Looks like it's got one mark there towards the back, a little mark right in the front. It's like dirt marks more than another one there towards the back. Well, put my screw up again. This time I'm gonna put a little more force on it. Stuck it in that time. Let me try to get it out. Well, I've got 2 or 3 little marks towards the very end. I've got one right here, about 1 inch away. I've got a pretty long one right towards the front. I've got one here about 2 inches away. Another little one here, another little one here. Several right here in the very end. So the marks are pretty much evenly spaced across here. All that really tells me is I've got a lot of dirt and grime in the spindle, and it's never gonna really mark, but it's marking the shaft pretty evenly, which does tell me that my taper is about correct. So now I'm going to put it back in the lathe here and use a finer tool and see if I can smooth this out and get it to the final diameter. Alright, we're back in the milling machine. I can see how that spindle's gouging the... See? You can see this on the camera, but the spindle's just gouging up the arbor. Now I'll work on that a little, but basically I've got still 3/4 of an inch here. I'm going to try to take another 5/1000 off and see if this will bring this a little closer in. Alright, I cleaned that up as good as I can with some sandpaper. Return that down about 3/8 of an inch. Doing a little marking here. Good. So now I got some at the end, a little right here in the middle. So pretty much all the way around right here on top. And we're down at the end, so this tells me what the it's pretty much in the, I don't know if you can tell, but right in here there's a little tiny contacts as well. So looks like this was pretty good. I mean, if I had a good arbor, I'd have more confidence, but it definitely looks like it's making pretty good contact all the way down the shaft. And as far as an arbor goes, this is going to have a drawbar holding it in. I'd like to get this a little closer. Maybe I'll put it in the lathe and try one more 2/1000 pass. See how close I can get it. If I don't want to get it too small or run into the shoulder, and then I'll have a lot more work to do. I'll try one more little pass on it. Alright, the last pass I made here was this little tiny carbide insert, which it did a pretty good finish. But I'm going to change to a high-speed steel round bit and see if that'll give me a little better finish this time. Alright, it's pretty good. I got this down to 3/8 of an inch. Give myself a little for a cutter or for a wrench. I pulled my arm down here. I got enough length on that. It's this might go in another 1/16 of an inch once there's some pressure on it. And I've got plenty of room here to do everything. So now what I have to do is machine this big part down and all of this to a 1-inch diameter. I should have tried for 1 1/4. I don't know how much I got here. Let's see. Yeah, 1/140. It's too small to try for 1 1/4. So I'm going to machine this down for a 1-inch length or a 1-inch diameter. And it's a shame. I should probably keep that taper because that was a really good taper. I can always do it again, I suppose, but I mean, once we've got the offset and everything all set up here in the lathe, it's kind of seems a shame to waste it and not cut another good taper. I got one more piece, and let me see if I can find it, and I'll put it in there. I decided to finish one good piece instead of start on another one. Anyway, I just put my my tailstock here, and I tried to line the centers up best I could there. I don't know, this thing's supposed to have a good zoom on it. Yeah, you really can't tell, but that's about as good as I can get them by eyeball. Might be off thousandths or so, just to roughly align the tailstock, and then I'll do a little checking on it a little later with some different stuff. Right now I've still got this. I'll get it set up to cut, and then we'll check it again for precise alignment. Yeah, we got quite a bit of hogging to do now. We're going to take out about 1/8 of an inch off of that main shaft, and that big one's got to come down to the same size, 1-inch arbor. So just a lot of machining to do at this point. I'll just continue to machine this shaft down. I can only take 25 thousandths a side, because 25 thousandths total, 12.5 a side. You can see the chips are coming out of there, kind of straw colored. Ideally they'd be coming out blue, but they're not getting that hot. The reason why is that belt is slipping. If I put more on it, it starts to bog and slip the belt, and it'll jump off. So I'm going to have to try to buy another belt. But it's kind of slow, 25 thousandths at a time, but at least it's getting somewhere. We got 10, 12.5. They give us 25 thousandths. Yeah, chips still coming off, golden straw. They're not really getting hot enough, but still getting a pretty good finish across the shaft. I'm about ready to make one long pass across the shaft, take both diameters, and see how straight I actually got it. Alright, I'm taking 20 thousandths. I don't know if this camera will show, but look down there in those chips. Ones that are coming off now are kind of silver, longer. And that pile right there is kind of straw colored. So these silver ones that are coming off right now is about a 20 thousandths cut. They're not getting hot enough to change color. It's giving a pretty good finish, but carbide tools apparently like a much hotter chip going on, more aggressive cut. Anyway, I just thought that was kind of interesting that the colors of the chips would be that different, 5,000. Alright, at this point I've turned this kind of hot. I've turned this shaft down now, clamped in the 3-jaw. This is a pretty expensive, fairly good chuck. It's has 2 thousandths run out, which is pretty good. But this, I don't need 2 thousandths run out on this shaft, so I'm going to reclamp it in the centers and turn it all true to the centers, just like this taper is back here. Right now it's 10 thousandths too big. I need to turn this piece down to a size that I can put a nut on, and then I'm going to have to thread this end. Alright, here's a Bridgeport piece. Won't fit. Here's the nut that goes on it. You can see it's same thread as that. I don't know what that is. Probably 4 or 5 threads an inch. I'll measure them. But what I want to do is save this nut and use it on this shaft here. Now the way this went, it had a center hole drilled in it, and then this fit inside a bearing of some sort on the bridge port. Well, my little arm here, I don't know if you can see here, let me measure, I'll show you. Alright, on the outside it measures 6/17, and on the inside it measures 6/90. So what this actually is, I'm not sure, but I'm pretty sure that it's a Morse taper 2. Now if I get I've got a lot of Morse tapers up here because that's what the lathe is. Probably a drill bit would have a Morse taper 2. Alright, this is a Morse taper 2 drill bit. Now if I move that out of the way, see, this fits in here real nice. This is I'm almost 100% positive that that's what this is a Morse taper 2. I know this drill bit is, so I think that's what that is. And so what I'll do is just machine this in with a 60-degree in, and I won't have to have a big long place here for bearing. I can take the thread right to the end, and then basically this will have a live center in it or something like that. I may wind up making something with a Morse taper 2 and a bearing in it. I'm not exactly sure how I'm going to work that, but what I do know for now is I need to turn this diameter onto this shaft long enough to put that nut on and thread it. Alright, I broke out my good digital gauge here. This is a 125 25 thousandths, and this thing here, I measured this and it marks is exactly 1 inch. So that's what this whole shaft needs to be, is a 1 inch. And right now, see, this is just going on there just snug. It's 25.5, maybe 26 thousandths, 26 ten thousandths. So I'm about 3 thousandths over right now, and it's a little warm. So I'm going to try to just take one pass in there. I'm trying to think. I think I probably should, since the whole shaft has got to be the same size, it don't make sense to turn a couple inches of the shaft for the threads and then redo the whole thing again, put it on centers. So I'm just going to go ahead and put it center to center right now. We only have one setup. Alright, pretty much got it set up. I put a bolt and a couple nuts on here to try to make up the imbalance. That runs pretty good. It's shaking a little bit, not much more than it usually does. I think I'm pretty much on center here. Well, I know I'm on center, but I'm just cranking this in a little to just get a little touch. Yeah, I'm going to have to move it. I can't get all the way to the end there. So all I'm doing is loosen up the tailstock. back a little. Hear it clatter in there because I don't have it tight. Now I got some drag on it. There we go. I don't know how much I got there. Maybe 1,000. Yes. It's doing a very fine cut. It doesn't look like it's getting any bigger or smaller. So I'm sure I have the shaft here all centered. Next thing will be just to make sure that I'm cutting it equally all the way around. I don't have an interrupted cut. It kind of looks like I do have. Yeah. Yeah, it's a little bit interrupted. So, and also this is not really the best of finishes. This is high chrome steel, so I don't know what I'm going to do here, but I'm going to try to get it all down to a 1-inch exact size, or pretty close to it, and then maybe file it and get it nice and shiny. This shaft here, obviously this is ground. There's no way I'm going to be able to get this kind of finish, not with this lathe and the tools I have, but I can get it where it's pretty close. Anyway, I'll do a little playing around with tools and bits and things and see what kind of finish I can get here. Well, one of the biggest mistakes I found that I've made is I get close to the dimension and then I go too far and ruin the piece. So I thought I had 10 thousandths from one check that I did on this, and once I got it all clamped up and everything else, I didn't have 10 thousandths. I only had like 3 or 4 thousandths. So it really wasn't enough to run a bit over it, because it needs about 5-10 thousandths to make a smooth cut. So what I did was just draw file this. I've mic'd it here. I'll just see if I can do this one-handed, which is probably not going to work. Let's see here. Yeah, maybe. Yeah, not going to work. But anyway, I've got this all within 1/2 thousandth of let's see, there's 0.001, 000, 0.001, 0.01. I'm a 10th over there, but I've got it within 1/4 thousandth all the way across here, which is pretty good. Now I'm just going to use some emery cloth and polish it up a little bit and see how much better I can get this thing to work. Well, it all looks pretty good. It's pretty shiny. It's obviously not a ground part, but about as good as I can do. If I'd had it bigger still, I would have been able to turn it down to a little better finish. I'm still learning how to do that, but anyway, the real test is to see if the 1-inch spacers and stuff will fit over it. Well, I didn't measure these, but they're going on real nice. I've got just a little snugness right here. It's probably just the grease, but they go on real nice all the way up the shaft. Just drag just a little right there, but I can't feel any play and down or sideways. This little spacer's got some play in it, but this is more like a washer than it is an actual spacer. But I'll pull a few more of these spacers off and see how they work. Yeah, they all went on there perfectly well. Looks like it was made for it. It actually was made for it. So anyway, I did a pretty precise 1-inch shaft. I'm probably within 1/4 of a thousandth, and it's probably a little bit undersized. It's definitely not oversized because I've got the stuff to fit on it. Next thing is to do all the gear change and stuff. I've got to go back here to this business on the lathe here and fool around and change some gears and set this thing up to do thread cutting. But as far as what we got now, I've made my shaft. Let's see what it looks like in the mill. Well, there we go. Fits on perfectly well. Goes in. I'll be able to use these various spacers to put in cutters wherever I want. I've got one more big one there, and then of course this nut is going to screw on here somewhere. I want to have enough room to make sure that I can do everything, but looks like my shaft went on real well, and my spacers went on. I've got to thread this end here, and pull these spacers off of here. And I kind of touched it a little bit, sort of locked that in, but I need to cut the other end and drill and thread it for a drawbar to hold this all in. But right now my back kind of hurts. I've been at this all day, and took this from an 1.25 inch piece of chromoly steel down to a semi-finished milling arbor. Basically all I got to do is thread this end and thread the other end, and I'll be finished with this.